Hello, we'll discuss about the electrolysis. Electrolysis is a chemical process which is taken place when the electricity is passed through a compound or the solution which contains iron. Electrolysis is taking place when we send electric current through a solution, which solution should contain ions. That can be an alkali solution, acidic solution, or when we dissolve salt in water, it is a salt solution, and if not, we can use a molten salt, fused solution. When the electricity is passing through such a solution, a chemical change is taking place. Then that initial compound is broken into simpler compounds. The solution is called an electrolyte. These are the electrolytes we use in electrolysis. Electrolysis is done in such a setup. This setup is called the electrolytic cell or the voltmeter. Electrolytic cell or the voltmeter. This contains a beaker or any container, and the electrolyte is put into this electrolyte. And here these are called electrodes. They are called electrodes. These electrodes are graphite electrodes. Graphite means carbon. Here we don't use any metal to conduct the electricity or to supply the electricity to the electrolyte. We use carbon because they are non-reactive, non-metals but conduct electricity. And then these two electrodes are connected to a direct current supply. This is the battery here. Direct current supply. These are the wires and this is the overall setup. When the electrolyte is fed into this, we have to pass the electricity, and in the battery this is the positive terminal and this is the negative terminal. Positive terminal and the negative terminal. The positive terminal is connected to a certain electrode. That electrode is called the anode. What is it called? The anode. The positive terminal of the battery is connected to the anode. The particular electrode is called the anode. Second one, the negative terminal of the battery is connected to the other electrode. It is called the cathode. Cathode. Now we have learned two new words, anode and the cathode. Anode means the electrode which is connected to the positive terminal. Cathode is the electrode which is connected to the negative terminal of the battery. Now let's see what is actually happening when the electricity is fed into such an electrolyte. The actual process is called decomposing. Electrical decomposing. Therefore, first of all, I'd like to teach you the meaning of the word decomposing. Look at this. This is the common limestone. Everybody knows that. Limestone means calcium carbonate. This is a very common equation. Calcium carbonate can be heated and it is turning into calcium oxide and carbon dioxide. Lime, calcium oxide means normal lime powder, and carbon dioxide. This is an example for decomposing reactions. What's the meaning of decomposing reactions according to this? Starting with a single chemical and finishing with many simpler chemicals. Starting with one complex simple chemical and we have obtained some simple more than one chemicals. Such type of reactions are called decomposing reactions. Therefore, in electrolysis also taking place such a reaction. We start with a single chemical and we can finish it up with many simple other chemicals out of that. Now we will electrolyte, we'll do the electrolysis for water. That means we are ready to break down water by passing electricity using that electrolytic cell. And here in electrolyting or electrolysis of water, we load this equipment with water to increase the conductivity. We use some acid. Therefore, this is called acidulated water. We put some of acid because acids can increase the amount of protons in the solutions to increase the conductivity. So conductivity is increased by this acid. Therefore, it is called acidulated water. Then we switch on this circuit. Then the electricity is moving through the solution. Now you should know what is happening. For that, we have to analyze step by step what would happen inside this. At the first step, first of all, we should know what are the things containing in the electrolyte. The first thing is water. It contains water, H2O. Water is broken. Water can be broken into, right, H plus ions, positive protons. These are called protons, and hydroxide minus ions, H plus ions and OH ions. These are in the aqueous medium. Water is broken as that. Secondly, this can be acidulated with any type of acid. Here, as an example, I think HCl, right, might have been used. So therefore, H plus and chlorine minus. Or else I can put any other, just another acid that will take sulfuric acid, H2SO4. Right, if I have taken H2SO4, it is as H plus and SO4 sulfate minus ions. Or else I can use another acid. What is that? Nitric acid, HNO3. If it is so, it would be broken into H plus and nitrates. It is clear now how we degrade, how we break these things into ions. So as an example, I have taken nitric acid. Right, then what's the next step is, first of all, we have identified what are the ions in the solution. These are the ions. And the second step is, we should know which of these ions will move into these anode and cathode. Look at the anode. Anode is connected to the positive terminal. Therefore, it is the positive terminal. Cathode is connected to the negative terminal. It is the negative terminal. Now, what are the ions in the solution? Hydrogen plus, altogether hydrogen plus ions, OH minus and nitrate minus. All the positive ions are attracted when they are in this solution. The positive ions are attracted to the cathode. These positive ions are called cations. Cations are attracted to the cathode. What are the cations present here? H plus. And anions means negative ions. Negative ions are attracted to the positive terminal. There are two types of negative ions. OH minus, NO3 minus, nitrates. Now we have clarified two types of ions near these terminals. Now here, in the electrolysis, what we have done first, we have put the electrolyte specific and identified what are the ions in it, and then we saw what are the ions going, which of them are going to the anode and the cathode. The third step is identifying which ion is acting actually near the cathode and the anode. Look at this. Near the anode there are two kinds of ions, OH minus and nitrate. And near the cathode, luckily we have only one ion. Now we'll see which ion is reactive more fastly. For that I have a series here. Positive ions here, negative ions here. And the decomposing ability is increasing towards the down. More the ionicness or the more the reactivity, lesser the discharging ability. Therefore, they are not taking electrons or giving electrons. Most unstable, most non-reactive things will gain electrons or give electrons in this reaction. So remember this. This is very important. Just keep this in your mind. Now just imagine we have only hydrogen here, no competition with positive ions. But when we come to the negative ions, look here. In negative ions we have OH minus and nitrates. So which is the most discharging ion? Nitrate or OH? Because ability of decomposing is increasing towards the down. Therefore, OH will be the changing or reacting thing here. OH. So I will select OH and hydrogen according to here. OH and hydrogen. In the third step, we should select what are the, hereafter we don't want to deal with other ions. Now we'll write the anodic and cathodic reactions. Anodic reaction. Now first of all we'll select near the anode reacting ion is the OH ion, hydroxide ion. And then I'm going to start with hydroxide minus ion. In hydroxide minus ion is changing. How it is changing? It is minus mean it has electrons. It has electrons. Therefore, they release electrons. What is happening near the anode, OH, and turning into two water molecules and oxygen and 4 electrons. When it is balanced, this should be 4 OH. Just remember this equation. 4 OH ions can turn into 2 molecules of H2O, 1 oxygen molecules and 4 electrons. And started with a negative charge. Now no any charge here. Therefore, such kind of reaction electrically, now it has gone to from negative to 0. Therefore, such reactions are called oxidation reactions. Oxidation. Anodic reaction is an oxidation. Always the oxidation takes place at the anode. Oxidation takes place at the anode. Oxidation. Oxidation takes place at the anode. Right. In cathodic reaction, we have to observe what is the ion near the cathode. Near the cathode, hydrogen plus signs are present. Then we'll start with hydrogen plus ions. Plus signs means protons that they are lack of electrons. That's why they have the positiveness, lack of electrons. Therefore, they have the ability of taking an electron and turning into hydrogen atom. And if it is happening in another time, another hydrogen atom, Together it would make 2 hydrogen plus 2 electrons and H2 gas. So when this reaction is taking place, hydrogen bubbles are arising here. You can see some bubbles. And also at the same time here even there can be some bubbles. What may be the reason? Because in the cathodic reaction we saw the production of oxygen. These bubbles are because of the gas oxygen. These bubbles are because of the gas hydrogen. Gas oxygen and gas hydrogen are produced by this reaction. That means the water is broken into oxygen and hydrogen finally. In the electrolysis of acidulated water, anodic reaction was this. 4 hydroxide ions are turning into water, 2 molecules of water, 1 molecule of oxygen and 4 electrons. This is an oxidation. Why we call it as an oxidation? Because we started with negative and went to 0. And cathodic reaction, 2 hydrogen plus ions and 2 electrons are turning into hydrogen gas, 1 molecule of hydrogen gas. And started with positive and gone to negative, therefore this is a reduction. Reduction reaction started with positive. In static electrical, if something is started with positive and going to 0 or negative, we call it a reduction reaction. And if we start with a positive 0 thing and going to 0 or negative thing and going to 0 or positive, it's an oxidation. That's how we do the classification here. This is as an oxidative reaction, this is as a reduction reaction. And overall reaction together, I did the sum of this one and this one. So therefore overall reaction is 4 hydroxide plus 2H plus 2 electrons and 2 water molecules with 1 oxygen molecule, 4 electrons and 1 hydrogen molecule. 4 electrons to 4 electrons are here. Look at it again. Yes, before that we have to multiply this with 4. Then this is even ending up with 4. This one will be 2 hydrogen. And therefore 4 electrons. And here even 4 electrons. 4 electrons to 4 electrons are cancelling. I think altogether we have 4 hydrogen and 4 electrons. That's all. Now the final things are 4OH minus plus 4H plus turning into 2H2O plus oxygen plus 2 hydrogen molecules. Finally, the water is breaking into, final reaction can be written as hydrogen and oxygen. If you want to balance this, we have to put 2 here and 2 here. So this is the final reaction. We can have 2 molecules of hydrogen and 1 molecule of oxygen. Finally, after breaking the water is broken by the electricity here. Electrolysis means breaking down or decomposing a chemical, single chemical into simpler chemicals. So the electrolysis is done here. Now today you have learned what is called electrolysis and how it is done and how the oxidation reactions and reduction reactions are identified and how these chemical reactions are written, ionic reactions are written and balancing. Okay, we'll meet again in another electrolysis. Thank you.